Okay, 2.4. This is the proof of the chain rule. Now this kind of gives us an idea of how that chain rule works. And so in this case, I would like to take the derivative of f of g of x with respect to x. And so I need the limit as h goes to 0 of f of g of x plus h, right? Yes. Okay. Minus f of g of x all over h. And so in this case, how are we going to make this work? Well, notice that if I multiply by 1, right, nothing happens to the limit. We know that. And so here I'm going to multiply by 1 in a very sneaky way. So I have my f of g of x plus h minus f of g of x, like that, divided by h. Now, when I multiply by 1, I am going to use g of x plus h minus g of x divided by g of x plus h minus g of x. Pretty sneaky, right? But what that allows me to do then is, again, as long as the individual limits exist, I can break up this product into, and move my pieces around, and so I have the limit as h goes to 0 of f of g of x plus h minus f of g of x all over g of x plus h minus g of x, and times the limit as h goes to 0 of g of x plus h minus g of x all over h. And so that was mighty tricky. Now, hopefully the second part is pretty obvious that is g prime of x. Now this first part, notice that, okay, since g is a continuous function, it's nice and smooth. Well, smooth really has to do with the derivative, but it's a nice continuous function. Then as h goes to 0 here, g of x plus h goes to g of x, and so g of x plus h minus g of x goes to 0. And so what you have here is sort of that other notation for a derivative, in that, if we look here, I'm going to come down here and kind of go over to the side here. If we look at the limit as, say x1 goes to x of f of x1 minus f of x over x1 minus x, right? That's an alternative form of our definition of derivative, and that's exactly what's happening up here, is that if you think of this as x1 and that as x, then we have the situation right here. And so this part, this limit on the left, is just f prime of g of x. okay, times that g prime of x. So rewriting it here again, just to make sure we see, we get this is our derivative of that composition. So there you go. There's our proof of the chain rule, and so now we completely understand it, I guess.